So now we're on to our second property of exponents, which is going to involve division. So we're talking about situations where you have two things being divided with exponents involved. And just like the last video, the best way to go about this, at least for the first couple problems, is to write it out and expand it and see what we're dealing with here. So x to the fifth means I have 5 x's being multiplied up top here. And on the bottom, I have x squared, so there are 2 x's down there. So what's happening is I'm multiplying up top by a bunch of x's, and I'm dividing by a few x's in the bottom here. So multiplying by x and dividing by x cancel each other, so like these can cancel each other, and these can cancel each other. So after those go away, I still have 3 x's left over, and they're all up top in my problem. So that's going to be an x to the third power, because there are 3 x's being multiplied. And on the bottom here, there's nothing left, so it's really over 1. But like you guys know, when it's over 1, we don't even bother writing it. So the answer to this problem is just x to the third. Similarly, on the second problem here, if you think about it, I'm going to have 9 x's up top and 3 x's on the bottom. So I'll write it out at least this one more time here. We have 9 x's and we have 3 x's here. And just like before, a couple of these x's cancel. Those cancel, those cancel, those cancel. What I end up with here is 6 x's. So I have x to the 6th power for my answer, and I could put over 1 if I really wanted to, but it's not necessary. On my last problem here, I have 4 x's up top, and I have 10 x's on the bottom. And as you guys are probably seeing by now, it's fairly tedious to have to write this out, so obviously this isn't going to be the way we always do the problems. But to set things up, to get an idea of what's going on, it's helpful. So 4 of my x's up top will cancel with 4 of my x's on the bottom, and I end up with 6 x's left over, but this time they're on the bottom of the problem. So I'm actually going to put my x to the 6th down there. I have nothing left up top, so I'm going to put a 1 there. In this, when it's over 1, it's whatever, you don't have to write it, but when it's 1 on top, you do need to write it to show that it's actually a fraction. So you get 1 over x to the 6th on this problem. After doing a couple of these, it should be somewhat apparent by looking at this that all we're doing here is subtracting our exponents. 5 minus 2 gets me a 3. 9 minus 3 gets me a 6. This one is a little bit different. There is a way of making it work with the subtraction. If you do 4 minus 6, you get x to the negative 6th power, just like we kind of did where we just subtracted the exponents here. And if you guys recall, what we do is we send it to the bottom here. We get 1 over x to the 6th. So you can actually just straight up subtract your exponents every time, like I did right here. But when you have more x's or more of the exponent on the bottom, it's easier if you just do subtraction like normal, but stick it on the bottom like I did right here. That's kind of leading us into our big rule for division. And we'll try some more complicated problems on it. So when you divide, you're going to reduce the coefficients like you normally would, and then you're going to go ahead and subtract your variables to see how many actually cancel. So here's the actual rule written out. If you have the same base right here, x and x, and we have different exponents, or whatever our exponents are, we subtract them to get our answer. So let's try out a few examples. On this first problem here, notice we have 10 on top and 4 on the bottom for our coefficients, like right there. If this was just a regular fraction, just a plain fraction, you would reduce those two numbers. You divide them both by 2, you'd get 5 over 2. It works the same way with this. Those are just numbers. If with a fraction you reduce it, that's what's going to happen here. So you do need to actually reduce the fraction like you normally would. Don't start doing weird things with subtracting these. These are just numbers. If you look at the x's here, I have 8 x's up top. I have 2 on the bottom. So 2 x's will cancel. There will be 6 x's left over, and they're all going to be up top because there were more on top. So I have x to the 6 right there. And I have 3 y's up top. I have 1 y on the bottom. There are more y's up top, so we have 2 y's left over after the cancel, and they're up here. So this is my final answer. I can technically put that 2 more in the center here so it looks better, but that's what we end up with after we simplify things. On my second problem, again, 14 over 18, you just reduce that like you normally would. You get 7 over 9. 12 x's up top, 19 on the bottom. I'm going to have 7 x's left over, and they're going to be on the bottom. And with my y's right here, I have 30 up here, 21 down there. There's going to be 9 left over, and they're going to be up top. So this is my answer for number 2. On my third problem here, I have some negative exponents in the problem. And if you do the power through it with the subtraction rule, you can do -4 minus 3, you get -7, you deal with it, and it would work. But I recommend you rewrite the problem here without any negative exponents first. So this x to the fourth right here is going to get, sorry, x to the -4th gets sent to the bottom. So I have my x to the third, and I'm going to have an x to the +4 right next to it, because it's getting sent to the bottom here, so it pops down on the bottom. And I'll deal with that in a little bit. This y to the -8th right here is going to get moved up top, turn into a y to the +8. So this guy goes up here. And this y to the -5th is actually going to the bottom. So I have a lot of stuff moving around on this problem. I kind of shifted things so I had no more negative exponents. Now I'm ready to actually get my answer here. So 9/12 reduces to 3/4. I have 8 y's up here and 5 on the bottom. There's going to be 3 y's left over, and they're going to be up top. And I have an x to the third and x to the fourth side by side. Remember, when they're side by side, you add the exponents together. So I get x to the 7th for that one. And this is my final answer. Last problem here. I have 4 to the 5th over 4 to the 7th. Remember, when the number has an exponent, it's not like a coefficient anymore. You don't treat it like a 14 or an 18 like here. You treat this like a weird looking variable. This is like, pretend it almost looks like a y. So pretend it was y to the 5th over y to the 7th. There are going to be 2 4's left over, and they're going to be on the bottom. So my answer is this, which I could even go and make 1/16. And that's my final answer.